So we have understood how to find derivative, the formulas of how to differentiate, and this one just needs more and more practice. There's no other solution. Then we learned how to find equation of tangent and normal, both of them. And now we have to how to find the turning point, if any. Turning point is what? Turning point, or the stationary point, or the vertex, or the minimum maximum point. So many names for the same thing. Stationary point, minimum maximum point, vertex. This is where the direction of the curve changes. So it can be like this, it can be like this. Both of them, the curve is coming up, coming up, coming up, and then this is the point where the direction of the curve is now coming down, coming down. So this point is your turning point, and over here, this point is your turning point. This one will be called the maximum, definitely. It is the maximum your graph is going, and then it is coming down. And this is your minimum. The graph is decreasing, 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 and then it is increasing. So this is the minimum point. Both of them combined, you can call them the stationary point, the stationary value, and the minimum maximum point, and vertex and turning point. So all of these are the names for the same thing. Now, one more thing interestingly is that if you want a tangent on a turning point, it will always be horizontal, isn't it? The tangent at a turning point, you can see it is horizontal, so the gradient is zero. So this means that the for to find the turning point, what do? You set the dy by dx to zero, which you know is the gradient of the tangent. So this is the thing that you do. You find the derivative and then you equate it to zero. And then find the values of x. Then solve to find x. And those x coordinates will be the turning points. Turning x coordinates of the turning points. As simple as that. Now this thing won't tell you if it is minimum or maximum. This will only tell you the coordinates of the turning point. Does not tell the nature. Does not tell the nature of the turning point, which is if it is minimum or maximum. It will get you both of them, because in both of the situations you can see the gradient is horizontal, sorry, the tangent is horizontal, and so the gradient will be zero. So if you have, let's suppose y is equals to x square minus 2x plus 1, they're asking you to find the turning point. So first of all, you will differentiate. So dy by dx, we know that we would use the basic formula. The power comes down and multiplies, and the power subtracts. And minus 2x will become minus 2. And plus 1 would become 0 because it is a constant. And because we want to find the turning point, we would set this dy by dx to 0. And now you would solve this. So 2x minus 2 is equals to 0. So x will come out as 1. And when your x is 1, you will find the value of y, which will be 1 square minus 2 plus 1. So this would become 1, 1, and minus 2, 0. So this means the turning point is 1 comma 0. And if I show you on your Desmos as well, you will see x square minus 2x plus, sorry, plus 1. Turning point is what? 1 comma 0. We got the same one. So this differentiation can help you find it very easily. You could have found it using the completing a square form as well, but this is also another way of finding the turning point. So you just find the derivative using the formulas, and then you equate it to 0 and solve the equation. You will get the turning point. This is it. If you want to make any notes or take a screenshot, now is the time. Now you have the background. Why are you equating to 0? Because the tangent is horizontal at a turning point. And horizontal tangent means the gradient is 0. And gradient of tangent is 0. This means dy by dx is 0. Because dy by dx is the gradient function for the tangent. सही है रयान संजय मोहित मोहित को
यस
तो
सर।
पता ही है।
जी सर ठीक है, मेरे लिए तो ठीक है।
Now you'll have to just do some more questions on how to find the turning point. Matlab, you know how to find, but finding the turning point. Practice questions. Where is it? Find the coordinates of the turning point on each of the following curves and determine the nature of each of the. Okay, we are going to ignore this part, the second part. First of all, we will learn how to do some practice on finding the coordinates of the stationary points. So let's suppose I'm taking this one. Y is equals to 4x square plus 8x power minus 1. Okay, so first of all, definitely differentiate. So this becomes 8x and minus 8x power minus 2. Power comes down and multiplies, and power reduces by 1. And then you would set this thing to 0 because you want the turning point. So 8x minus 8 upon x square is equals to 0. You can move this over there. 8x is equals to 8 upon x square. X square would go over there, multiply. So 8x cube is equals to 8. X cube will be equal to 1, and therefore your x comes out as 1. And now if your x is 1, your y comes out as 4 1 square plus 8 upon 1, which will be 12. So the turning point is 1 comma 12. Now still we don't know if this is a minimum or maximum. We just know that this is the turning point. It can be minimum, it can be maximum, any of them. And there's, okay, I'm not going to go there over here right now. By the end of the class, I'll tell you how. And there's also a very simple thing. So to find a turning point, differentiate it, equate it to 0. Differentiate it, equate it to 0, and solve. That's it. Not very difficult, I think. Okay, I'm doing another one. Let's do this one. So y is equals to x cube plus 48x minus 1 plus 4. So you want to find the turning point, so dy by dx. Differentiate. It will be 3x squared minus 48x minus 2 plus 0. Equate to 0 because you want to find the turning point. So 3x squared, 0 is 0. Don't even write it. You can move the minus 48 on the other side. So 48 upon x square. This would go over there and multiply. So 3x power 4 is equals to 48. X power 4 is equals to 48 upon 3. Sorry, 48 upon 3, 16. So x will be 4th root of 16, which will be plus minus 2. And then you will find two values of y because you have found two values of x. So there are two turning points. If x is 2 if x is minus 2. So y is equals to 2 cube plus 48 upon 2 plus 4. Y is equals to minus 2 cube plus 48 upon minus 2 plus 4. So this would become 8 plus 24 plus 4, 36. So 2 comma 36. Minus 8 minus 24 plus 4. So minus 20 minus 28. So these are the two turning points. We don't know which one is minimum, which is maximum, but we know that these are the two turning points. Any questions, anyone? How to find a turning point? Okay, so you people got it right. The answer for part E for elephant, it is 4 comma 4. Then this is another way that they're gonna ask you a question, but the logic is similar. They have told you that this is the curve equation, okay, and they have given you the turning point. They have given you that dy by dx is 0, which is the turning point at x value minus 3. So first you find the derivative of the equation that they've given you. So this would become 3x square plus 2ax minus 9. And for the for the turning point maximum point, we would equate to 0. And we know that this is 0 when your x value is minus 3. So now you can substitute your x as minus 3 and then find the value of a. So this becomes 27 minus 6a minus 9. So a will come out to be 18 divided by 6, it is 3. This is your answer. Okay, you people get it? Any questions? You are doing the opposite. They have given you the turning point, they're asking you for an unknown in the equation. Previously, we had the equation, we found the x coordinate of the turning point. They gave us the x coordinate of turning point over here, and then we finding an unknown from the equation. So it goes both ways. The logic is, clear. Okay. Continuing, the next thing that you should know is how to know if it is a the nature of the turning point, if it is minimum or maximum. There is there are essentially three natures of a turning point. It can be minimum, it can be maximum, it can be neither. But right now, because of the limitations of the syllabus that we have, we would have only a turning point which is minimum or maximum. Maybe you'll go into university later on and explore further about this topic. But right now, we have to identify now if the turning point is minimum or maximum. And the easiest way is to double differentiate, find the double derivative, okay, and input the x coordinate of the turning point in it, and find value of the double derivative at that turning point. If your double derivative is positive at that point, the point is minimum. If your double derivative value is coming out as negative, then your that point is maximum. This is the condition that you will use now. Copy this down as well. Now let's check which one is minimum, which is maximum. So we have found these turning points in this one. Now we will check if they which one is minimum, which one is maximum. We have the equation as well. We have the derivative as well. This is your derivative, the first derivative. So you will find the double derivative. So d square y upon dx square, which will derivate the same way. So this would become 6x, and this would become plus 96x power minus 3. You have found the double derivative. And now input the x coordinates of the turning point. So if x is minus 2 and if x is plus 2. So find the value of double derivative. If it is minus 2, 6 times minus 2 plus 96 times minus 2 cube, negative cube. I think this would be positive one. Negative, I think this would be negative value. 6 times minus 2 plus 96 times minus 2 minus 3. Negative 24. Which you can see it is less than 0. This means that this point is a maximum. And if your x is 2, 6 times 2 plus 96, 2 cube, which will become 24, positive 24. So this is more than 0. This means this is a minimum point. This is it. This is how you find if it is minimum or maximum. Any questions? Let's do another one. We found this one, right? So if we continue, if we want to find the turning point, sorry, nature of the turning point, you would differentiate it again. So the derivative was this part, your first derivative. And if you want to differentiate it again, this would become 8 plus 16x minus 3. And now if your x coordinate of the turning point is 1, so the value of the dy by double derivative, it is equals to 8 plus 16 1 power minus 3, which is coming out as 24, which is positive, which means that this is a minimum point. This is it. This is how you do it, finding if it is minimum or maximum.
सर
Okay,
यहाँ
Sanjeev.
पे 8 1 नहीं हो जाएगा?
Oh yes. नहीं नहीं सही है 8 would, why would it become 1? This is the 8x. The derivative of 8x would become simply 8. And the power just comes down, multiplies, so plus 16. And x power minus 3. सही.
सर x to the power 0 1 नहीं होगा? अच्छा okay.
X to the power of 0 would become 1, so you'll only be left off with this coefficient 8.
हाँ okay, I got it.
Hmm. Good. Okay, let's see what do we have more. This is one of the applications of differentiation. So regardless if you have the same variables x and y, or if you have any other variables theta and r in this case, everything works the same way. So if you read this question, they have given you a sector and a piece of wire of length 40. So this means this complete thing is 40, is bent to form a sector with radius r and theta radians. The total area is a. So we know the sum of the sides, it is 40. So 40 is equals to r plus r theta. This is r theta, right? The arc length, which will get you 40 is equals to, if you take r common, so 2 plus theta. And they have given you the area is includes, the area is a. Okay. So area is a is 1 upon 2 r square theta. They're asking you for the first part, express theta in terms of r. So we have to make the theta subject. So this would become 40 upon r is equals to 2 plus theta. So theta will be 40 upon r minus 2. This is the answer to your first part. Show that your area is 20r minus r square. So area formula we have found, it is half r square theta. And the theta now you can replace it with the thing which we have formed, 40 upon r minus 2. And if we expand this now, this would become 20r 1 upon 2 r square into 40 upon r minus 2 upon 2 r square. So r and this r square cancel out, 20 and this 2 and this 40 becomes 20. So area comes out as 20r minus r square, the one which they have given us. Look, we have found the second part as well. Find the value of r for which there is a stationary value of a. Stationary value of a means the derivative is equal to 0. So you will find the dA upon dr. You will differentiate this equation for the stationary value. So which will be equal to 20 minus 2r. And then equate it to 0 because we want the stationary value. So the derivative is equal to 0. And now you found the value of r, which will come out as 20 is equal to 2r. So r comes out as 10. And now we have found determine the magnitude and the nature of this stationary value. First we have to find what is the stationary value. So for that thing we would need to find the area. So area when this radius is 10, so area is 20 times 10 minus 10 square, which will be 100. 200 minus 100, which will be 100. So 100 centimeter square. This is the maximum value or the minimum. Let's see. Nature of this. We know that this is the stationary value of the area. But is it maximum or minimum? We will have to differentiate it again. So double derivative d square a upon dr square, which will be the derivative of this thing, which will be minus 2, isn't it? 20 derivative will become 0 and minus 2r becomes minus 2. And you can see this is negative, which is less than 0. This means this is a maximum value. So this area is the maximum. This is your complete question. Any questions, anyone? Forming the equation first, and the rest of it is finding the stationary value, finding the nature. It's the same. Just your variables are different. Instead of x and y, you have a and r.